Hello students, today we will start our unit 3 ZTransform. The books that you'll have to refer for the third unit is A. Anand Kumar and Alan Oppenheim. Now we'll start with the introduction part. As we have already studied about the Fourier transform in previous classes, and we have studied that the Fourier transform is used for continuous time system. But here the Laplace transform is also used, but we don't have Laplace transform in our syllabus, but we should know a little bit about it. Now there are many signals for which Fourier transform does not converge, but the Laplace transform does. Now the Laplace transform allows us to perform transform analysis of unstable system. As I've mentioned here, that it is allowing the transform analysis of unstable system. We use the same approach in the discrete time as well. In discrete time system, we develop a Z-transform, which is the discrete time counterpart of the Laplace transform. Now the Z-transform is definitely a very successful tool in the analysis of linear shift invariant system, as we have made use of Fourier transform in the case of linear time invariant system. The Z-transform is used for the analysis of linear shift invariant system. It is very well suitable for solving difference equations with initial conditions as well. The range of values of Z for which the x of z converges is called the ROC of x of z. Now we'll be further discussing about the ROC of x of z. ROC is nothing but the region of convergence of x of z. X of z is the Z transform of any particular sequence. Now coming to the next part, the bilateral or two-sided Z transform of a discrete time signal. Now if the signal exists for both the side, that is for positive n side or the negative n side or a sequence, basically we call them as a sequence, then in that case the Z transform is defined as x of z equals to summation n minus infinity to plus infinity x of n z to the power minus n, where x of z is a complex variable, where z is a complex variable. Now this definition is used for the bilateral or two-sided Z transform, where x of n, this small xn, exists for both the side, that is for positive n side as well as for negative n side, and z is, as we have already discussed, it is nothing but a complex variable. Now coming to the second one, that is which is another one-sided or unilateral Z transform, and the z of x of z, which is the Z transform of one-sided signal, is defined as summation n 0 to infinity x of n z to the power minus n. Now this is for one-sided signal. We even call it as unilateral signal, unilateral Z transform. Now coming up to the ROC part, region of convergence. What basically a region of convergence is? The set of values of z or the set of points in z plane. Basically the z plane, z is nothing but a complex variable that we have already studied. Now in the z plane we'll be having a real axis and an imaginary axis. Now in z plane, the set of values for which the x of z converges is called the region of convergence. Now to define it in a proper way, we'll be having the z, x of z, it will be like a plane where we will be having a real axis, real z, and the imaginary axis and imaginary z. Now this entire plane where we'll be having the real values of z as well as the imaginary values of z is nothing but a z plane. Now the values which exist in this plane are the values which defines us the region of convergence. The set of values of z or the set of points in z plane for which x of z converges, for the points in the z plane for which the x of z convergence is called the region of convergence, ROC of x of z. If there is no value in z, that is no point in the z plane for which x of z converges, then the sequence x of n is said to be having no z transform. This is very important, students. If there is no value in no value of z in the z plane, if we are not having any point in the z plane for which the x of z converges, then the sequence x of n is said to be having no z transform. Now we need to remember this point very carefully. Now the advantages of Z transform. The Z transform, as we have already discussed, it converts the difference equation of the discrete time system into linear algebraic equation so that the analysis becomes easy and simple. It converts the difference equation of a discrete time system into linear algebraic equations so that the analysis becomes very easy. It also has the advantages that the convolution in time domain is converted into multiplication in Z domain. We already know that the convolution in time domain is converted into multiplication in Z domain. Now Z transform has a major advantage that it exists for most of the signals for which discrete time Fourier transform does not exist. So these are the three main important advantages of Z transform. Now coming up to the Z transform of some common sequence. Okay. We'll start with the first one, which is the unit sample sequence. We even call it as unit impulse sequence. That is nothing but x of n equals to z del n. Now the del n is defined as it is equals to 1 for n equals to 0 and it is 0 for n which is not equals to 0. Now, as according to the definition of x of z, which is the z transform of xn, or the z transform of xn is what? It is del of n. Hence we take it as summation n0 to infinity, because it is simple at del of n exists only at n equals to 0. Hence we are taking this particular example of unilateral sequence, that is n0 to infinity del n z to the power minus n, which is nothing but 1 for all values of z, because del n will have the value only at n equals to 0 and the rest of the value of n, the del n will be 0. So del n has the value 1 at n equals to 0 and del n is, as we have seen here, it is 0 for all other values of n. That is, the ROC is the entire z plane for this particular sequence. If the sequence is a unit sample sequence or a unit impulse sequence, the Z transform is 1 for all values of Z and the ROC is the entire Z plane. Now the second one is unit step sequence. Unit step sequence is x of n equals to un. Un, as we all know, it's a unit step sequence which is 1 for n greater than and equals to 0 and it is 0 for n less than 0. Hence, for taking the Z transform of it, we'll apply in the formula x of z equals to z x of n z u of n, where u of n is a unit step sequence, summation. Again we are taking this the formula of unilateral sequence, because u of n is a unilateral sequence. It exists only for n greater than and equals to 0. It doesn't exist for n less than 0. So it is for n equals to 0 to infinity u of n z to the power minus n again. Now this one is the formula n summation n0 to infinity 1 into z to the power minus n. Now coming to after applying the formula, this becomes a series where it is x of z equals to 1 plus z to the power minus 1 plus z to the power minus 2 plus z to the power minus 3 plus, and it goes on till infinity. Now the series can be written as 1 by 1 minus z to the power minus 1. After applying the geometric progression in that, it can be written as 1 by 1 minus z to the power minus 1, or else we can even write it as z by z to the power minus 1. Now this is the complete Z transform of the sequence u of n. The above series converges. It it is saying that this above series, which we have written as z to the power z by z to the power minus z by z minus 1, converges if z to the power mod of z to the power minus 1 is less than 1. It is coming from here, from this particular equation that we have written, 1 by z to 1 minus z to the power minus 1. It converges only if this value, that is z to the power minus 1, is a lesser value than 1. Then only this entire x of z converges. That is what we have written here. Mod of z to the power minus 1 is less than 1. That is, ROC is defined as mod of z is greater than 1. So from here itself we can define our ROC. Here we have written mod of z is less than 1. That is, ROC can be written as mod of z is greater than 1. So the ROC is the exterior of the unit circle in the z plane. Here we'll be plotting a ROC which will be like this. Will be a real z. This is an imaginary z. This is the center. We'll plot a circle whose radius is 1. From here to here the radius is 1. So this circle is known as a unit circle. This circle is known as a unit circle because its radius is 1. So what is the ROC? It is saying the ROC is the exterior of the unit circle in the z plane. Now the exterior of the unit circle means the entire z plane leaving the unit circle. That is the exterior of the unit circle. So the z plane just leaving the unit circle will be the ROC. This is the ROC, the exterior part of the unit circle. Leaving this unit circle, the rest of the part in the z plane will be the ROC. So this is the ROC of the sequence u of n. If the sequence is u of n, in that case the z transform is z by z minus 1. We can even write it as 1 by 1 minus z to the power minus 1, and the ROC is mod of z greater than 1. This means that it is the exterior of the unit circle in the z plane. Thank you.